So I can post this up on YouTube later on. So like I said, this is the 230 study guide. There is some difference between the 230 and 240 test, but usually the biggest thing is like you might get asked one more type of question that you've seen before versus and then maybe one less of like the metric to metric conversion. One of the things that is commonly asked and worth going through is the whole like going from well, first of all, doing like a weight-based heparin protocol. I think you should know how to do that at this point. But one of the things that I think a lot of the fourth semester students have been asking me about is these are all heparin questions, going from micrograms per minute to milliliters per hour. And then also, how do you know to go and do that? But I don't want to jump the gun and start reviewing something that you already have a good grasp on. You tell me either unmute or in the chat, just let me know what you would like to work on today. Okay, you mean just do like a regular review? That's fine. I can do that. So I will say, even when I do these regular reviews, because you guys are fourth semester, I try not to. I'm not going to waste your time with going through metric to metric conversions. I think you know all that, so I'll just go over the ones that I find are the ones that are asked most and most challenging, and then we'll go from there. That's perfectly fine. So thank you, Erica, for that recommendation. So. Okay, so I'll go off with this, and then I also have another version of this that I'll show you. Actually, I'll show you that one first, but let me just clear this off real quick, because we'll go through this just because this is good review of what to expect, and then I can also practice my dimensional analysis with you guys, because I think that's a good thing to review. All right. All right, so before I do that, let me switch my share. Let me go back to that first share screen that I had shown you. So this is the Allegheny campus review sheet. And one of the things that I like to call to is this dopamine question, because in this dopamine question, it does talk about making a conversion where you're going with a weight-based infusion rate to a fluid-based infusion rate. Okay, and usually weight is going to be associated with this. So sometimes it gives you the patient's weight in pounds, and I'll give you an example of that and how to set that up. Or sometimes it's just going to be based off of or they'll give you just the kilograms straight out, which was, I think, a preferred method of seeing that type of question. So anyways, what we're going to do is, so for this one, the way it's written out is, and then doing the long dimensional analysis, we're going to take a 70 kilogram patient and we're going to multiply by the 5 micrograms per kilogram per minute. Okay, so that's step one in the in setting this up, is just getting rid of the kilograms, and then you're in micrograms per minute. Now, the other thing is, it'll tell you, what rate should the nurse begin the infusion. You need to know what we're looking for, because that's also going to be helpful. If it tells you rate, you know that you're looking for one of two things. milliliters per hour or drops per minute. Okay. And then if they wanted you to find drops per minute, what they're going to give you is they'll tell you something like in a microtubing, or they give you a drop factor showing you like the drops per ml of some of the item that we're talking about, or of the medication we're talking about, or the tubing that we're talking about. And so since it doesn't give you drops, any kind of drop indications, then we know we're not dealing with this, and we are dealing with this flow rate, milliliters per hour. Okay. That's helpful because now you can go on and you can say, okay, well, I know I don't want minutes. I do want hours, right? So 60 minutes. Then you're in micrograms per hour at this point, after you kind of account for the minutes. We can't proceed because our available, or our stock, is in milligrams, but our order is in micrograms. So I need to convert the micrograms to milligrams, or you could convert milligrams to micrograms. It's really up to you. But since we're already kind of in this flow, let's just go ahead and convert micrograms to milligrams. So we know that there are 1,000 micrograms in a milligram. And then that accounts for the micrograms. Now we can go ahead and convert milligrams to milliliters. And we have 250 milliliters because this is our available 400 milligrams. We plug that into our calculator. 70 times 5 times 60 times 250. And then divide by 1,000, and divide by 400. And I'm going to get an answer of 13.125. And that's what the key says in this. But your answer should just be 13.1 mil per hour. So the only thing that really changes with these questions is it starting off in milligrams per kilogram per minute, or milligrams per minute? Is it starting off in micrograms? And you could see that there's a couple of conversions, right? We got to convert minutes to hours. We got to convert or account for the patient's weight. And then we have to convert the milligrams per hour to ultimately milliliters per hour. So the only thing that would change for this question would be like if we had a patient weight in pounds. So let's just say we had a patient that weighed 120 pounds. Then you would need to account for that, right? So you need to convert pounds to kilograms. You know how to do that, right? 2.2. Then you would multiply by the 5 micrograms kilograms per minute, and you would just follow the same procedure that you did up here. So I'm just going to say ... You just kind of continue that on. Then when you get to your final answer, if need be, round to the nearest 10th, and then that will give you your answer. For Allegheny campus, I always tell the students to take the 120, divide by 2.2, and like that gives you 54.5454 repeating. So I would tell them just to use 54.5 kilograms as their weight, and then plug that into the rest of the equation. And then, but I know at North, they don't want you to do that. But I will say that at least what I've noticed is that whether you do the rounding for these types of questions, when we're talking about adult patients, although I guess 120 pounds, that doesn't necessarily constitute an adult, but someone who's over like 100 pounds, the rounding doesn't seem to have, it tends to come out with the same answer anyways. But so you're consistent with what you're doing at North, then please, make sure you write out your long dimensional analysis and then do your rounding at the very end. One of the things that you might run into, and why I have this circled here, is you're going to have where they're going to order a medication, and it might tell you extra information that you don't need to know. And so part of the challenge with this is just figuring out, well, what do I need? How do I figure out what I need and what I don't need? So your order is always something you need, right? So the order is 200 milligrams. Then it says the available is 100 milligrams via IV. I think there's a word missing there, but maybe via IV. And then you look at the label. So this is almost like a reconstitution question, okay? Because it tells you, oh, I have 100 milligrams of furosemide, but I don't know the strength in order to calculate the volume. Because if you're looking at this, when you see IV, you already know that you're looking for milliliters, right? So even if it doesn't tell you how many milliliters of the drug, you would know that you're looking for milliliters because IV, SC, IM, that is going to be delivered via milliliters. So on the label, it tells us 30 milligrams per milliliter. So those are the two data points that we would use, and we would ignore the 100 milligrams because that just tells us the total. Okay, so that to me sounds a lot like a reconstitution type question. All right, for this one here, I crossed this out, and the reason I crossed this out is because it tells us that we have an IV. The total IV volume is 500 milliliters. Then it tells us we have an infusion rate of 120 milliliters per hour, but I want to know what the infusion rate is if we brought it through a tubing that has a drop factor of 15 drops per milliliter. Okay. So when I do that, and if you're following dimensional analysis, you might be sitting there going like, well, what do I do? Like now I have this extra milliliters. The only reason we would need the 500 milliliters, the total, is if I wanted to know how long that IV solution would last. But because I am not making that calculation, we can ignore that and we can focus on our flow rate and then our drop factor. And if I take my flow rate, and I'm just going to save a step here, times my drop factor, and then you're going to get 30 drops per minute. So again, this is just a reminder to look at, pay attention to what the questions are asking, look for those distractors and don't get distracted. This is another question with extra information. So this is, again, this is very similar to having like a reconstitution, but this is actually a flow rate question. So it tells us your patients receive Solu-Medrol 200 milligrams IV. That's important to know. We want to make sure they're getting the right medication at the right strength. It's received from the pharmacy in a 120 milliliter bag, and it's to infuse over 30 minutes with a drop factor of 10. If they give you a drop factor, a lot of times they want to know what is the drop rate. Okay. If they don't give that to you, then they might be looking for a flow rate. And there's other questions that could be asked from this, such as if they wanted to use that IV and then calculate how many milliliters were coming in. There's ways to do that, but they'd have to just give you that information. So for this one, you would just take the 120 milliliters over the 30 minutes times the 10 drops per milliliter, and then that would give you your answer for this question. All right, and then I'll show you a different version of the heparin protocol. Give me 1 second. So let me go back to the study guide. All right, so the study guide, and this was put together by a student at Boyce, and she gave me permission to look at it and share it with you guys. This is a good additional questions about like the micrograms per minute and things of that nature, and then converting that to flow rate. And flow rate, if we're not talking about per, if we're not talking about drops, we're talking about milliliters per hour. So it tells you that we're going to start a patient on a nitroglycerin drip. And you can see at 5 micrograms per minute. It says you notice the nitroglycerin is mixed at 25 milligrams in a 250 milliliter bottle. And then it gives you a concentration of 100 micrograms per milliliter. It wants to know what is the flow rate in milliliters per hour. I actually don't need to email it to you. It's already in the, everything I'm going over is in the OneDrive folder. So you can just access it. Don't access it now because I'm working through it, but you can go in and you can access it through the where it says click here for practice tests on the email you should have received, or on Black. I don't know if they posted it on Blackboard. If you click on that, it opens up a OneDrive share folder, and then you'll see it listed out: Allegheny, North, Boyce, South. You might have to look around for some of the things. Most of my stuff is in the Allegheny folder, but I have been piecing together some stuff for North and for South and for Boyce. Boyce is where you're going to find what I'm working on right now. The Boyce folder, Boyce 230 folder. Okay, so let's do a couple of these conversion problems here. All right, so for this one, we have a couple pieces of information. It tells me 5 micrograms per minute. I like to draw in red, so let's get that going there. Okay. So 5 micrograms per minute. Then it says you have nitroglycerin mixed in 25 milligrams in a 250 milliliter bottle, but then it also tells you that the concentration is 100 micrograms per milliliter. So that's actually going to help us save a step. Okay. And then it wants to know what is the flow rate, and then it even tells you in milliliters per hour. So what I'm going to do is I'm just going to make a conversion, right? So I'm going to take my 5 micrograms per minute times, and you can do this either way, any way you want to, but since I know I'm going to hours, I'm going to do 60 minutes per hour times the one, I want to get rid of micrograms and I'm converting to milliliters. So 1 milliliter, 100 micrograms. So I'm going to take 5 times 60, which is 300, divided by 100. And that just gives me a very slow infusion of 3 mil per hour. I'm going to do the same thing here. So it gives us an initial infusion rate. This is, again, a nitroglycerin drip, micrograms per minute. It tells us we have a 50 milligram per 250 ml availability, and then we want to know what the flow rate is in milliliters per hour. So unlike question 25, it doesn't give me the microgram per milliliter. So I have to make sure that I make that conversion before I come up with my final answer. But we can do that. So I'm going to start off, and I'm going to start like I did the previous question. Start with my 20 micrograms per minute. I'm going to convert the micrograms per minute. I'm going to convert the per minute. I'm going to convert that to hours. Then, because my availables in milligrams, I know I need both my order and my available to be in the same unit. And since I'm already working through this and I'm in micrograms, I might as well just go ahead and make that conversion to milligrams. So I'm going to convert from micrograms to milligrams. Again, 1 milligram is 1,000 micrograms. Now I can account for my available: 50 milligrams, 250 ml. Make sure I did everything right. So minutes, gone. Micrograms, gone. Milligrams, gone. What am I left with? Milliliters and hours. So just plug that into the calculator. 20 times 60 times 250, and then divide by 1,000, and then divide by 50. And then I get a whopping 6 milliliters per hour. Just seems so unimpressive. Okay. This number 27 was asked during the review on Tuesday. And basically this should be like almost a little bit of a recall to when you did your pediatric dosage calculations during third semester, where you're basically calculating a range, right? So this is the start of the range and this is the end of the range. So it tells you we're following this protocol. We're going to start them at 15 and work them up to 200 micrograms per minute. And so basically we want to know what we're going to start the infusion rate at and what we're going to end the infusion rate at, and then basically just kind of titrate it as we move along. So it tells us a couple pieces of information. So I'm just going to indicate, like, if you saw this earlier, I had said this is the start and the finish, or point A to point B. So in order to prepare the solution, you have 50 milligrams of the medication, and then the total volume is 250 ml. Okay, so that's important to know. So what that tells me, and what it should tell you, is that our available is 50 milligrams per 250 ml. So now we can do some math. I'm going to take my 15 micrograms per minute. So it's my start. I'm going to pretty much do what I did exactly above here. I'm going to convert minutes to hours. Then I'm going to convert micrograms to milligrams. Then I'm going to convert milligrams to milliliters. And I'm going to get the bottom, or the starting point of my range. So 15 times 60 times 250, and then divided by 1,000, and then divided by 50. And I'm going to get 4.5 milliliters per hour. So that's point A. I also need to calculate and account for point B, and that goes all the way up to 200 micrograms per minute. And I'm actually going to follow the exact same steps that I've listed above. So I'm just going to do this here. This is just, I would tell you to write this out. I'm just doing the quotes to indicate that it's the same conversion factors coming down. So once you know what it is, you can quickly just put it into your calculator. 200 times 60 times 250 divided by 1,000 divided by 50. And then you'll get the top of the range. You're basically going to titrate this starting at 4.5 ml per hour and working up to 60 milliliters per hour. Now, the only other thing that usually kind of causes stumbling for at least for Allegheny nursing students is the heparin protocol, but I think a lot of it is just the way that their heparin protocol is written out is a little bit differently than what you'll see at North, South, and Boyce. Yours is pretty straightforward as far as it gives you the details right there in the context of the question. So it's just a matter of converting patient's weight into pounds to kilograms, and then multiplying by what the bolus dosage strength is, and then converting that bolus dosage strength in units to milliliters. And then the same thing for the IV. The infusion is converting units per hour to milliliters per hour. And a lot of it is just, if you've done it a couple times, you probably feel pretty solid about it. But if you don't, then the best way you can practice this is if like you go through and you look at number 14 and you're like, how do I practice this differently? Just change the patient's weight. So make them 130 pounds and then just practice it. And then still round your answer to the nearest 10th when you get to the end. But just practice it. You'll get better just by practicing different weights. So you'll notice that I did an example here. I used a 175-pound patient. So that's what this answer is for 175 pounds, as opposed to the question asked for 110 pounds. I just did a variation. And then these are just other examples of the same heparin type protocols that, again, it just comes down to practicing. All right, so I'll stop here again. Any questions on any of these, or any ones that you'd like to see a variation of? Like I said, these are the ones that usually create the most challenges for anybody taking the fourth semester test. So yeah, okay. Yeah, I imagine your way is the same way that I'm doing. I might just be putting it in a different order. So that's fine. Yeah, if you're getting the same answers, then yeah, believe it or not, when it comes to math, there's more than one way to get to the same answer. And then when you understand it at a certain level, you're like, and you look at it and you take a step back, you're like, oh, okay, you just did, I did A, B, C, you did, or let's say I did A, D, C, B, you did A, B, C, D. And so you're doing it, as long as you're getting it right, you're doing it right. Okay, so for number 8, I'm assuming you're talking about on this packet here.
Yes.
Okay. No. And the reason being, at least you can't do ordered over half directly, because you are doing a flow rate question. So technically, you want to set it up. I would recommend doing it dimensional analysis like I have written up here. So like for Allegheny campus, let me just rework this problem. So I did this one just a little bit ago. But let me do this so you can see how I would set this up. So first of all, like when you're doing these and you know that you're looking for an infusion, which means you're either looking for one of two things, milliliters per hour or drops per minute. And if it doesn't tell you either one, like it doesn't give you like what, units or anything like that, the way you can figure out what you're dealing with is looking at the context of the question and realize, okay, there's nothing in here about tubing factor, drop factor, or anything like that. So we know we're not dealing with drops per minute. We know we're going to be converting to milliliters per hour. So that's the first thing. Then after you know that, then you can make some changes here. So the first thing you want to do is you want to take the patient's weight and multiply it by the given there, the 5 micrograms per kilogram per minute. So before you do any kind of order over half with, like I said, I don't think that would work very well with this question. because it's a flow rate question. Okay. And then you're going to get 350 micrograms per minute. So just before you do anything with converting and getting to milliliters per hour, you first have to make some changes to this. You need to convert that minutes to hours. So there's a lot of steps in this, even though it's a short problem, there's a lot of steps in here. So 350 times 60 is a big number, right? So let me get my calculator. 350 times 60, and I'm going to get 21,000 micrograms per hour. Now I have another problem. The order's in micrograms, but the availables in milligrams. So I need to convert either micrograms to milligrams or milligrams to micrograms. I always advocate that since you're already here, and you probably already know just to move the decimal point over 3. But if you don't, just as a review, if I'm going to convert micrograms to milligrams, 1 milligram is 1,000 micrograms, which will give me 21 milligrams per hour. So at that point, then once you get to here, then yes, you can do ordered over half, but you got to do all these workup steps before you can get to doing ordered over half. So when you're here, now you can take your 21 milligrams per hour divided by 400 milligrams times the 250 ml. But there's some workup that you need to do before you can just do ordered over half with this particular question.
Okay, that actually helped. I was getting confused. I was getting stuck on 21 and
then where do you go from there? Yeah.
Yes. Okay. Yeah.
And that's why, like, if you were just to do dimensional analysis, and that's how I've worked it out. So like if you come back and watch this replay, at the beginning of the replay, I went through this problem and talked about, like, and just did it with just straight dimensional analysis, just as a way to kind of show you all the steps. And then the benefit of that is before you do any kind of multiplication or division, you can see that you've eliminated all the units and you're left with what you're looking for.
Okay, thank you.
You're welcome.